All right, we're in my favorite building, Building 26, Windows World. Please introduce yourself.
Yeah, my name is Melur Raghuraman,
Mm-hmm.
and I'm a Principal Development Manager
Excellent.
in what is called Windows Fundamentals, and I manage the team that's responsible for diagnosis and supportability.
Excellent.
It's a part of the core operating system division.
Mm-hmm.
And this group was established sometime during Vista to bring focus on diagnosis and supportability issues in Windows.
Sure.
Windows is one of the most complex piece of operating system or piece of engineering ever created. It runs upwards of, I don't know, it's last count, 70, 80 million lines of code, and it's got thousands of binaries. Earlier we used to be able to install using floppies, and it became CDs, and it became DVDs, and now it's like, so the amount of code that it packs is just immense. Every day, the volatility of the ecosystem it's live. There are so many new device drivers released every day, hundreds of drivers touched and released every single day. Applications are orders of magnitude higher. Right?
Yes.
So in such an ecosystem, problems happen.
Yeah.
Right? And when problems happen, the end user expectations are it's an appliance, it's a device. Why doesn't it work like a phone? I don't need to be a computer geek to solve problems. I want these problems to disappear in the first place, never happen, and if it happens, let me find solutions very quickly, easily, resolve it for me. Mm-hmm. And if I have to get somebody's help, make it easy for me. Right?
Yes.
These are all the kind of expectations that people have, and we kind of think about this deeply, and then see what we need to do in the operating system that will make these things a lot easier.
Absolutely. And now, of course, you've been on Channel 9 before, because I remember interviewing you and part of your team.
Yes.
For the Vista timeframe for Diagnostics. So let's talk a little bit about quickly, what Vista did, which was definitely a step in the right direction to where we are today with Windows 7.
Okay. So in Vista, what we started to assemble was basically look at how is this diagnostics problem. When things go wrong, how should one fix itself? And we looked at other industries and said, well, you're going to need some kind of detection. You need to know that the problems are taking place. And then once you detect them, you need to be able to get to the root cause of problems. And then you should figure out how to resolve the problem and solve it for the end user. To detect the problem, you're going to need one extra step, which is instrumentation. Right?
Yeah.
Just like cars have dials that indicate what's going on, mm-hmm. or engine scopes that have information, you need instrumentation. So we looked at these 4 steps. That is very generic in troubleshooting and problem resolution. And we said, let's put down the basics for each of these things. Put down the plumbing in the operating system. We spent a lot of time doing instrumentation in the OS. Our team owns ETW, event log, performance counters. So we put in lots of capabilities, instrumented the operating system with lots of events. You can go to ETW documentation and see all the instrumentation that's available. Then we also started to experiment with, put together a diagnostic engine that will essentially have code packaged as DLLs that will look for occurrences of specific problems. We went after a handful of problems, 10, 15 scenarios, occurrence of problems, and then figure out how to solve these problems. So through that exercise, we learned quite a bit. At the same time, we also looked at support. Windows operating system is used in a variety of ways. The PC prices are dropping, and then things are getting more complex. So where it hits the bottom line is on the support side. Customers pick up the phone, call support, happens for OEMs, ISVs, and Microsoft. When they call, these problems are very complex.
Sure.
And the person on the phone goes through multiple iterations. Sometimes they flatten the box, which really hurts the customer. So getting to the bottom of problems was difficult. So they needed some automation. All I need is ability to collect information from the client box, to diagnose problems. So we looked at these two ends of the problem. One, stuff that could automatically happen in the box, and then stuff that will help the support guys with automation. So we put together something called MSDT, the Microsoft Support Diagnostic Tool, and then diagnostic pieces in the box. And then we sat and watched all the data, telemetry, and the support data that came by. And what was really interesting was the in-box diagnostics were solving problems, scoped real problems it was solving, but the cost of creating more of these things was actually very high, because you needed to write code, you needed to write a DLL, you need to worry about localization, you need to worry about user experience. And when even in this building, I go talk to people, hey, for your scenario, do you need to build diagnostics? And they come back and say, well, I don't want to create another component for diagnostics, and I'm not a UI person, I'm not going to worry about the UI and stuff like that. So the cost of writing diagnostics was perceived to be high.
Sure.
On the other side, the support guys, even more interesting things happened. When we launched it and used it, support was getting benefit out of that. But what was happening was the data collection alone was not sufficient. And they somehow figured out a way to take some scripts and then shove it through the pipe that we gave them, and then launch the code in the user's box, and then fix the problem. All of a sudden, the customer sat went up, support call duration went down, and then we look, oh, that's very interesting. When problems happen, people don't care how, why, who. Right?
Exactly.
They want the problem gone. Right? The resolution capabilities to launch very quick resolution to problems was the key. That was the real big takeaway. And we have looked at numbers, and those cases where they had resolution actually reduced the call duration by a significant % and improved the customer side, which they had not seen in a while.
Excellent.
So we said that's the area to invest for the next release.
Okay.
So we said, let's think about how we would come up with a mechanism that is a low bar for entry for people to author diagnostics, so that they can just script it. They shouldn't have to write a whole lot of code, and the experience needs to be very uniform, because when a diagnostic that solves a particular problem, it shouldn't be any different. I go through the same steps. It should be, a single click if possible.
Yes.
And resolve the problem, make it just go away. They should be easily discoverable. So, if by and large, the OS should remain in the background, because the end user's experience with the OS is with whatever task they're performing with the OS, right?
Yeah.
And if they are interrupted, in my opinion, in rare circumstances, the operating system interrupts the user's activity.
Yes.
An egregious form of that is blue screen. Right? We just grab on the system and oh gosh, right?
Yeah.
But there are many other ways that the OS rudely interrupts the user through error pop-ups, dialogues, and stuff like that. So all of these are fair game in trying to make sure that the user's experience smoothly proceeds with the task at hand, and the OS doesn't interfere, right? But if it does, for whatever reason, the task is interrupted for whatever reason, you want the user to resolve the problem as quickly as possible in the context where the problem is experienced. So we thought about these things, and then decided that we need to build something that solves the problem.
Excellent. And here we have Windows 7.
Yeah?
So that's excellent. Let's talk about what you did. I've noticed, having using Windows 7 for, a long time now, that the Activity Center is one way that I get information. Like, wow, you need this driver. There's a problem with this driver. Here's a link right to the driver. Go install it. Thanks, Windows. That's really cool. So let's talk about how we got to that point.
Okay. So one of the things, and the Activity Center work was done by the WEX team and the fundamental joined together. Right?
Sure.
And it had a bunch of different objectives where you want the interruptions to the user quiet down. There are all kinds of notifications that are popping up, and then we want to quiet them down. There are multiple centers. Let's aggregate them towards one center, and then train the user to go there in case of help that they need.
Yeah.
And we actually latched on to that area for troubleshooting. Right? If you have a problem either the system draws you through notifications to the activity center, and then you can find out solutions for your problems, or if you experience problem as a user, where do you go? You go to the activity center and then look for problems to be solved. Right? So we worked on the troubleshooting aspect of the activity center.
Sure.
Right? So when you go there, what happens? Right? The scenarios that we wanted to enable basically was when a user experiences problem, can the user on demand ask for help, troubleshooting, and then resolve the problem without calling support, right? That was one big goal, right? The second part was we are not going to be the ones developing all the diagnostics for resolving people's problem. We need the OEM's help, ISV's help, other component teams' help, and so on. So obviously you're going to need a bunch of SDK tools that will let a whole bunch of people create diagnostics, because the problem space is so large that no single team can actually resolve all the problems. So we need some diagnostic authoring, publishing story with that. Right? Then the next part was we are not going to be able to package all the solutions to problems in the product, because some of the problems we don't know yet. And if you think about Windows operating system, you release it at a point in time, and then you expect it to work with all the applications from the past, and then work for all the applications that will come in the future, and also all the hardware that is yet to be developed. Right? So
Sure.
the bar is very high. So we cannot anticipate what problems end users will face, which means you need a mechanism to deliver diagnostic content from online. So that was obvious. So you need a story for better when connected. Diagnostics need to get better when connected, and solve new problems that you haven't seen before. And finally, is there a way that we can be proactive about it? This is where you can see the sort of future direction that we want to take this to, and we are experimenting with in what way can we proactively fix the problem without user having to ask for help.
Exactly.
Right? So those are the four themes that we touched upon, and in the process we built this infrastructure called scripted diagnostic infra in the operating system.
Excellent.
We also shipped a bunch of diagnostics for commonly faced problems for the end user in the box, and then we have ability to deliver more as time goes by through the connected story that I mentioned. So those are all the pieces that we built for Windows 7.
Excellent. All right.
So in Windows 7, we built this infrastructure called scripted diagnostic infrastructure. And the idea here is, let's take the PC, and I'll just put the
Can we use the black one?
Black one?
Yeah,
Okay.
thank you. Sorry to interrupt you.
No problem.
Okay.
Earlier I mentioned that you need to think about the diagnostic experience to the end user, right? And just to make it a little wider, and the diagnostic experience basically deals with how can we provide a uniform experience for any problem that user encounters, right? When they go ask for help, Activity Center is one aspect of that, and then when you go ask for troubleshooting, what steps does the user take, and what does the user see is something that falls into this bucket. And this one will interact with what we call as diag provider, right? Which comes with the in-box storage of diagnostics that we shipped with Windows 7 for commonly occurring problems that we've seen so far. The diag provider also seamlessly connects over the wire to what I mentioned earlier, the online experience, which we call as Windows Online Troubleshooting Service.
Okay.
And that has a couple of pieces. We use the response server, which what the Watson server uses to send responses. Right? That as a catalog to find, do you have new diagnostics available for me?
Great.
And then there is obviously the download center. Download server to pull the diagnostics seamlessly to the box and experience it, right? Now the diagnostics that you bring down they execute with the help of what we call as diagnostic engine. So it's a set of code that basically takes the diagnostics and runs it. Now here is the interesting part. We layered this on top of PowerShell as the scripting language.
Nice.
In Vista, we had kind of depended on code-based diagnostics. So people have to write C code, package it as DLL, think about the user experience. So the cost for writing these diagnostics was very high. So the learning from there was we needed to be declarative about writing diagnostics. You need to be able to quickly whip them up when a problem happens, and also think about a lot of goodness from that. We kind of settled on PowerShell. PowerShell is the new generation manageability story, right?
Absolutely.
And there is already lots of books written. It's been developed from ground up by people that are language experts. They've thought about security very well, and there is already enough mind share in the admin community who would be prime candidates that would be developing diagnostics, mind share available to whip up diagnostics for Windows platform.
Yeah.
So we said that's where we want to go. And in Windows 7, PowerShell ships in the box, right? So that was a natural choice for us to layer our scripting story. We don't have to go write a language. Our users don't have to go relearn another language. Yeah. PowerShell comes with all kinds of benefits, for us in the diag space. So that's one part. Earlier I mentioned the support aspect of this. Even the support platform can interact with the PC. This is the PC with these pieces. Support platform can also interact in the new model of scripted diagnostics using PowerShell to solve problems even when the customer makes a phone call, right? Hopefully we will solve a lot of the problems in box, right? So that's kind of a high-level overview. There is one piece that I mentioned earlier, the Diag authoring toolkit. My handwriting is not that good. that can create diagnostic packs, either ship them in box or through the online troubleshooting service, right? So these are all the pieces that we kind of created or glued them together. These pieces sort of different teams, but we glued them together so that you get this entire scenarios materializing, right? Now I would like to show a demo if possible.
Absolutely. And
then come back and maybe we can dive in deeper as to what we did with the schema. And
that sounds awesome. I'm just going to pause this while I move the camera. Okay, we're back.
Okay, so in this demo, what I want to show is I noticed that my glass is broken. I'm used to that, but it's broken. I don't know why. So in Windows 7, we are drawing people towards the action center, which is this icon here, for problems, finding solutions to your problems, one place. And there is a troubleshoot a problem option there, and when I bring it up, I see this CPL with a bunch of categories. And what we have looked at is the common set of problems, and you should be able to search and discover them. And you notice programs, hardware and sound problems, network problems, appearance issues. Oh, I see this display arrow desktop effects. I'm just going to go click on it, and it brings up the troubleshooting wizard. And all I have to do, the first one is basically shows that here is the publisher, and do you trust it, to say proceed further, and I click next. And now you can notice that it's detecting problems. It's going through the detection phase, and it's looking for various root causes. And then it's actually resolving the problem in one click.
Nice.
And you can notice that my arrow is back. And it's looking for more problems. Sometimes, one root cause may be hiding other root causes, so it's going through additional detection, and it says, it looks like your problem is resolved. What do you want to do next? And I'm done. I'm just going to close it.
Great.
Right? So it's back. So this is nearly a one-click experience for finding and fixing problems. Right? And this, what you see is the Action Center CPL where you see all of the troubleshooting content that we developed, right?
Absolutely.
Now I can sort of break it down as to what happened here.
Yes, exactly. And it would be interesting to know, sort of, as we take a little wander around your office, what exactly these diagnostic constructs are.
Okay.
So in other words, what does this diagnostic thing you're talking about look like that lives on the remote server or lives in the diagnostic store?
So let's take that. The diag content. Let's just talk about the audience first, and then I'll talk about what's in a package. There are two audiences. One is the user, right? User who's running the diagnostics, and then the person that's creating the diagnostics. Right? So we already talked about the bar has to be low for this person. It should be scriptable, right? I shouldn't have to write any UI, and I should just bring my PowerShell knowledge to the table, and then the user's paying, and then I can just whip up the diagnostics. I should be able to deploy this very easily. So once I create this stuff, if I'm an admin, I can walk around with a USB key with a bunch of diagnostics, and you call me, I can stick it in and then solve your problem. Or I can stick it in a website and let the user go download it and solve their problems.
Excellent.
So it should be easily deployable. From an end user point of view, the user cares for discoverability and consistent UX. Okay? And don't make me do a whole bunch of stuff. Just with a single click at most, I should be able to solve the problem. And then I definitely care about trust.
Yes.
Because this is code executing in my box. I don't want to go to some random website and click on something and catch something here. Right? So I have to be able to trust the diagnostics that are running, and it shouldn't cause any harm. Right? These are all the parameters that we kind of worked with. Now a diag package, is actually a directory, and under this directory there is first a file with the extension diag package, and this is one file, and it's got a bunch of files. I'll go through them. The diag package file is an XML file, and we have a schema published in the SDK, and what it contains is metadata about the capabilities of this package. What does it do? What kind of problems can it resolve? And it has the troubleshooting scripts, links to the troubleshooting scripts, links to the resolver script, links to the verification script. In fact, the life cycle that we go through is think of a problem in the view, particularly the author who's solving the problem should view the problem from a point of view of root causes. So this is similar to saying I go to a doctor and then I say, I have a hurt somewhere, right? That is a symptom. So the user is saying, I noticed this thing, but the doctor has to look deeper and then say, why is this happening? And that may be a root cause deep within the system that the user may not know, but the doctor knows. And the author will have to think about the root cause and need to know, how do I detect this, right? That's why doctors prescribe a whole bunch of tests.
Yes.
Right? So I should be able to detect this, and then once I detect that you have that condition, I should be able to cure it, right? Resolve in diagnostic lingo. And then once I cure the problem, I can also verify, right? In the doctor's office, verification may be asking the patient, are you feeling fine now? And in this case, we can actually script-wise verify that the condition has gone away. So this is sort of the model that we have in mind. So essentially list out the root causes for the diagnostic problem you're trying to solve, write scripts for detecting those root causes, write scripts for curing those root causes, and verify them. And if you have those things in PowerShell, you come to this diag package, which is an XML schema that lists all of these in a particular order. You don't have to worry about the schema. The authoring tool will take care of it. I'll show a demo a little later. And that's what basically the diag package contains. And then you will have these individual scripts, right? Troubleshooting script, resolver script, and verification script, right? We also have a catalog file, which takes care of the security aspect of the diag package. Catalog file is basically list of all the inventory in the directory, the files, their checksums, and they're signed.
Perfect.
So that we can trust that this package came from a trusted route, and we can execute. Right. So that's basically what the package contents are. Now the package, the whole directory can be actually cabbed, and then you can have a diag cab extension, right? And both the diag cab and diag package extensions are actually tied to an inbox exe called msdt.exe. Right? So you double click on, that's how the key scenario works. So you basically bring a diag cab and you double click on it, it will launch MSDT with that cab, and then that one will launch the diag engine, which will go through the steps to execute.
Outstanding.
Right? So that's sort of how it works. In fact, the msdt.exe will pick up the package and call into the diag engine, and then the first call it makes is initialize. It gives the path of the package, and the diag engine will basically go crack open the cab if it has to, or go through the directory, find the catalog file, verify that the package is safe to execute. That's the first thing it would do. Second thing it would do is, each package can have a run level. Some packages need to be admin only, or so it's going to verify that you are authorized to run it. You're at the right level to run it. Then it's going to also check for applicability. Okay. You can put some applicability rules to say this package works under certain conditions. You can check for those. So after it does all of that, it says I'm ready. Then the UX will say, okay, now go diagnose.
Okay.
When it says diagnose, the engine will say, oh, I need to go launch this troubleshooter script, and it will instantiate basically the PowerShell run space. So we actually instantiate a PowerShell run space and then supply the script to execute and go through the troubleshooting scripts. So we do all the heavy lifting of the UI and instantiating the run space and running it. All that the developer does, author does, is to write the script, basically, that does the logic. Right?
Great.
So the PowerShell runtime will load the script and run it, and now you have the script. You have a need for the script to go up to the UX for a number of reasons, right? So what we have done is we have actually built a number of commandlets, PowerShell commandlets that we ship in the box, which basically lets you do a number of things. The script can say, I do my script, whatever logic I want to do, and then I say, hey, I found a root cause. Right? So there is an add root cause script commandlet. Then it can also say, I want some input from the user. Sometimes you want to do the experience so that you prompt something to the user, or maybe give a list of choices and let the user pick one. So you have input commandlet, get input commandlet.
Sure.
Sometimes you want to provide progress notifications. Right? I'm doing this, and I don't want the user to go click cancel. I want to give some progress notifications. All the string that you saw flashing by comes through from the progress, notification from the script. Right? So there is progress commandlet, and then in the end, silently there is also a report being created. So this is update report is another commandlet that we have. So now the scripts can communicate upstream through the engine to the user.
Excellent.
And the msdd.exe basically talks downstream through the engine to the scripts. So the engine is the middle piece that orchestrates the life cycle of the diagnostic, like we talked about, for each root cause, detect, cure, verify part. The engine is orchestrating that and pulling all of this together.
So now one question I would have is, where does this, clearly there has to be some telemetry involvement here.
Absolutely.
Because you something bad happens on one computer, chances are it might happen on a million other computers.
Absolutely. Yeah. So the msdt.exe goes through the wizard that you saw, and we have telemetry attached to that. So we exactly know for people that are opting in, we hope a lot of customers opt into this because that will help us improve this continuously. We know what troubleshooters are being launched, and then at what stage, how effective they are, and then if they are not effective in certain cases, we pick up information about what are the conditions that we noticed that will help us improve the troubleshooters over time. And that telemetry comes back and we actually look at it periodically to say what improvements we have to make. Now here is the beautiful part. So as the telemetry comes back and we find out new root causes that can be solved, we can build an updated version of the inbox diagnostic package, park it in the online troubleshooting service.
Excellent.
Now once we do that, and the next time a user goes and does the same set of steps, the diag provider seamlessly will contact Watts and then find out that, hey, there is a new version of the troubleshooter available. Instead of running the inbox, I will download that and run it.
Awesome.
So you will get the benefit of additional root causes as time progresses.
So basically we're building an ecosystem of troubleshooters.
Yes, absolutely.
Which is great. So one of the questions I would have is some of the problems that happen on Windows, I'm focusing more on Windows, the system itself, in the sense that, let's say I have some sort of memory heap corruption or something really low-level problem. How granular are these troubleshooters? Yeah, so there are a couple of different infrastructures that we have to deal with, stuff like that, right? So PowerShell and the kernel, man. Right. Now, this particular infrastructure is intended for configuration-related problems most of the time. Sure. Right? Though I can imagine in certain cases it can be used for other areas. We've looked at a wide varieties of problems. There are connectivity-related problems. There are hardware-related problems. There are bugs, code bugs, in some cases, and the configuration problems are really egregious, where for whatever reason things get out of whack. Registry keys get whacked by somebody, or user does something in trying to get out of a problem. They get the system into a bad state. How do you get out of those kind of things? Is where we are sort of intending this. Okay. Right. I can show a couple of other examples where you will see what we are doing with this infrastructure. My apologies to the audience for the fact that this isn't being screen captured, but I'm old school, so they'll have to deal with it. Okay. Right. So I'm going to take. Before we dive into that, we talked about the authoring tool. I'll just briefly, show you that. Okay, great. We saw the audio troubleshooting, the Aero troubleshooting a little earlier, and this one is the Windows troubleshooting pack designer. It's the IDE for creating troubleshooting packs, and it ships in the Windows 7 SDK. And let me just go break glass again, so that you'll see. The troubleshooting. This is already loaded with the Aero troubleshooter, but user can go and create a troubleshooting pack with this. You will see the idea that I mentioned earlier about focusing on root causes. So here is one root cause that the theme service is not running, and then you will basically write a troubleshooting script for it, troubleshooting, resolver script, verification, and the metadata for each one of these. You don't have to know the schema, but the metadata is basically in a forms type of an interface where the user will, the author will simply type up whatever they want for each of these fields, and then we will generate the XML, that's the diag package content. And then let's just take a look at a script, for instance. So this is troubleshooting script for finding a service is not running. It's very simple. You notice the first line. Can you see this? Yes, I can. Okay. First line says write diag progress.
So which is one of the commandlets I was talking about, sending the progress from the script to the UX, and it says, I'm checking for service status. Right? Then there is a PowerShell command here that says get service. Get service is a commandlet that's available in the box, and it checks for the theme's service and is it running, right? Mm-hmm. So that's basically PowerShell way of checking it. And then we are calling the update diag root cause, which is one of the commandlets related to diagnostics, and it says for this root cause, you set the detected to be true, right? That's it.
Nice.
That simple.
Great.
So with this integrated development, all that the author needs to bring is their PowerShell knowledge, and they can create the package. And here is the beautiful part. Once you type the metadata and write your script, with one click, you can actually run it right here in the tool, and now the troubleshooter runs. So I didn't write any UI. All these UI elements are built into Windows 7, and you get the same standard experience as Inbox Diagnostics, and it goes through, it fixes my problem, my arrow is back.
Awesome.
And I can close and party on.
Perfect.
So we hope a lot of admins and ISVs, OEMs pick this up and create troubleshooters for their problems. Now, we talked about how does the user detect these diagnostics and get value out of it. Right? So one place was the Action Center. Right? Now, if I go to the Action Center, let me just show, we saw these categories.
Yep.
Now, if I go to View All, and then it shows all the troubleshooters. Now, I want you to sort of look at this location field, and you notice that there are online troubleshooters, local troubleshooters. So the local ones are in the box, and the online ones are in the Watt store.
Nice.
Right now. So over time, I would expect the number of troubleshooters we release through Watts will be more, and newer problems will get solved through this capability. This is one of them. Now,
one question I would have is, something that would be interesting would be a lot like how Windows Update works, right? So that the system in the background would go check the service, even if I don't have a problem. It's like, are there any new things here related to this operating system? Well, it's Windows 7. There's a bunch of new Windows 7 diagnostics up there in the cloud. Just bring them down, and all of a sudden.
That's a great lead-in. I'm going to show that. Okay. Right. Before I do that demo, there is one other demo I want to show, which will lead to the next one. So the next thing what we thought was, we draw people into Action Center, and then you ask for troubleshooting. In some cases, customers, users go to whatever application or whatever they are looking at, and in that context, can we provide the troubleshooting experience? Right? A good example is the new Device Center in Windows 7, devices and printers. Now it shows nice, view of the devices that the user can understand. Now you notice that I brought a printer, right? That's a USB printer.
Okay.
I plugged it in to my computer. And then I said, well, I'm expecting to print, but the device says, well, it's a USB printer, and the icon is not as good as other things I've seen, but there is a exclamation mark here.
Okay.
Right? Earlier, if you pre-Windows 7, people would have to futz around with the device manager, which is a totally geeky, experience, and then they have to know about drivers and this and that, right?
Yes.
So the particular problem here is, well, PNP, when you plug in a device, it should automatically load the driver and it should work, right? But in this case, happens to be a raw capable device, and the system doesn't, yet know that it's actually a printer, right? So the driver is not loaded, and I am expecting to print, and the device manager says there is a problem here.
Yep.
So all that the user will have to do in this context, I didn't go to Action Center, but I can just, in this context, I can click Troubleshoot. Right. Now, what this will do is pick up the, PNP ID, go look for a driver for this printer, and then it found it. It says, do you want to apply this fix? I'm going to go apply this fix and keep an eye on this one. See? It came back to a nice looking printer. So now the driver got installed and I'm ready to print.
Perfect. Now, one question I would ask you at this point is, in a scenario like that, why not just fix it?
Okay.
Why ask me to troubleshoot?
Yeah,
you know the problem.
Ideally, that's the way it should work, and most of the time it works that way.
Okay.
But there are a number of reasons why it doesn't work. There are, if you go to customize settings, somewhere here, device installation settings, right? So in this case, I have set it to automatically install when something is plugged in. Somebody, for whatever reason, it could be, oh, let me do it, and may have forgotten. Right?
Okay.
And then there may be other case. In this case, it happened to be a raw capable device. So even though it's a device, we don't know what class of device it is, right? So there are a number of reasons why, even though you want to do it, you cannot.
Sure.
And another example is there may be a response that's waiting there, and you haven't acted upon it.
Sure.
Right? And I want to print it now. I don't care. I haven't discovered it, but I want on demand. I say fix it now, and the system should fix it.
Yes.
That's exactly the scenario we are sort of addressing.
That's good.
Right? So now the next example sort of tends to the proactive model I was talking about. Right? We get a lot of telemetry, and we can analyze the telemetry, and then we can see what's going on, in the systems. One common way that is used is when people click on the Watson, crash information and say send this feedback, and we get this crash information and we analyze them in the backend. Right? Oftentimes it's a code bug, and we have to release an updated information through Windows Update or ISVs. Right? But there are a number of situations where it's not necessarily code bug, but something on the client side that needs to be fixed, and it's making stuff work badly. Or in another scenario, maybe Windows operating system has a lot of extensibility mechanisms where I plug in various things, and one of those plugins may be acting up.
Yeah.
As a result, my entire process crashes. Right? I don't, all I need is I want to keep this going. Maybe undo the one that's bad and let me enjoy the rest of the stuff, right? So there are a number of ways where a client-side action could actually make my experience a lot better than what it is. Right? So the example that I have is, we all use media player,
Yep.
and then we install codecs from here and there, and then if you pick up a bad codec from somewhere, and it starts to crash the media player. Right? Now that information would go up to the back end as media player crashed, but we can analyze it to find out what is actually crashing this. Right? Now, in this example, I go to Action Center, so I've already simulated my crash part of it. Right? So what will happen is from the back end, we have now the ability through the response server to say that go run this diagnostics on the customer's machine and get them out of this jam.
Nice.
Okay. So I go to Action Center, and it shows that I have a couple of responses waiting for me. So this is a notification that is waiting for me. So it didn't get in the face, but it shows that I have 2 issues that I can solve for you. User can go in, and here is the fix problems caused by media codecs, right? So I'm going to go view message detail. So it comes up, and usually it will direct me to Windows Update to download something, or to another vendor site to download things. But in this case, it says click to open media codec diagnostic. Right? So I go click on it, and then media diagnostic runs.
Nice.
Right? Now this diagnostic is not in the box. It's parked in Watt's store,
Awesome.
Online store. So by leveraging telemetry that's coming out of the box, understanding the root cause of problems, we can actually author diagnostics, park them in the online store, and shoot a response proactively to the entire Windows ecosystem.
Awesome.
And resolve these problems.
Okay.
So, and if I click on it, it's going to solve my problem. Right? It's downloading the troubleshooter. It's detecting that I have this problem, and it's going to go, fix it. Right? Yes, update some codec is a problem. It says go resolve it. Right?
Mm-hmm.
I'm going to go close this. Right? So in this case, I was supposed to go download the right codec.
Yeah.
I didn't, but I'm going to close it.
But you gave everyone the information.
Gave
that
you
they
the
actually
information
needed.
that you actually needed. Another example of proactive, you mentioned the proactive part of it,
Yeah.
is we have something called a maintenance troubleshooter.
Hmm.
What the maintenance troubleshooter does is once a week it wakes up and it runs as a task, wakes up, and then it looks for very basic common set of things. Right? And what we have noticed is one of the problems that people have is if your time in your system gets out of sync with your domain, problems happen that are not very intuitive. Right? Things don't work until somebody says, "Oh, go check your time." Right? It's a very simple thing. You may have played with the time for whatever reason and forgotten about it, or you and the domain controller may have drifted apart, and that's one scenario. There are other scenarios where we can do cleanups on the desktops, broken links, freeing up disk space, those type of activities that will keep the system come back to a healthier state over time is something that we can do. We are starting very conservatively with this idea, and this maintenance job in Windows 7 will do a few basic things. Right? So in this example, I go to Action Center, and when I open it, I notice that there is a system maintenance notification. So once a week when it runs, and if it detects some root causes, it will send a notification to Action Center, and I can go run the system maintenance. I go perform system maintenance, and it runs the maintenance troubleshooter. It's again looking for broken shortcuts. Is there any cleanup activity I need to do? Checks for volume errors, and then it basically fixes my time. Right? Troubleshooting is completed. Right?
Great.
So this is another example of proactive, troubleshooting. We would like to get there with more content, but we are sort of inching towards that area. But the main advance in Windows 7 is this scripted capability with the online store that will let us solve lots of problems that we haven't seen yet.
Absolutely, that's awesome.
Yeah.
Now, in terms of the future, not what you're working on for next versions, that's not interesting, but this is sort of the beginning of do you see a day where Windows will be able to do most of this stuff silently? So in some sense, if some driver is not working, the ultimate goal would be just fix it.
Yeah.
You can tell me after the fact, maybe in some history center, that here's what Windows did for you to make sure that, because a computer is not a human body, but there is some notion of the computer sort of acting like a homeostatic device, right? It deals with perturbations. It responds negatively or positively depending upon what it needs to do.
We think about it a lot, and ideally you would want that to happen. It's a nice thing to talk about, a nice scenario. One thing that is interesting to keep in mind is we don't know the user intent. For instance, if I go mute my speakers, is that a problem, or I don't want the sound? Don't fix it for me, right? Mm-hmm. In some other case, I may have muted the system sound, forgotten about it, and then I'm plugging in something, and then say, what happened to my sound, right? I just didn't happen to notice that, right?
Sure.
So the user intent is the unknown variable here, right? With that said, there are a number of things that the operating system can actually recover from, right? For instance, if you have, in fact, it already does. I mean, there are a lot of recovery built in which we don't actually see and treat it in that fashion. So, for instance, disks fail at a certain point in time, but prior to that, there are a lot of soft errors that are taking place. There are block errors, and system automatically relocates that block somewhere. The disk firmware does it to some extent, and then the operating system, tries to do stuff. We have a feature called Co-Fire, where we keep a cache of system binaries, critical system binaries for the system to boot up. And if the disk were to have a bit rot somewhere, and then you try to boot and that binary doesn't come up properly, then we detect that. And then we replace it from the cache and then recover the system. That's a completely silent recovery mechanism.
Nice.
Right? So in cases where we can do that safely without any ambiguity of user intent, we will attempt to do that. That's sort of our direction to pursue. But I have to be very cautious about whatever solution we put in code has to work under all circumstances, and that is where the risk is, right? Absolutely. So what you think is a fix may be hurting somebody else, and we've always be very conservative with diagnostics, where we don't want to make the system any worse than what the problem is that the user is trying to solve, right? If you can't actually get it any better, don't attempt to do it, right? Yeah. Because then it increases the annoyance factor. But with that said, we definitely do want to move. But the way it will manifest is somewhat the way I described, where we will get telemetry and then find out the problems that the ecosystem is facing, and somehow figure out a way to solve the problem proactively for you. So I don't know if you would term that as homeostatic, because I may have the problem, but I may yet to experience it. But sure, before I go attempt to do that, you've already come and fixed it.
Exactly.
Right. That may be a safer bet, to take. But we think about this a lot.
Absolutely. Well, I think it's one of the things that we all forget is sort of that we don't know if we forget it, but it's always good to remind ourselves that Windows is a very, 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 very general purpose operating system. And the fact is, it would be hard. It's one thing to make the operating system on Mars rover to be unbelievably redundant and self-correcting and whatnot, because it only does a few things.
Yes.
Compared to what's possible with a general purpose operating system running on thousands of different types of hardware. So it's somewhat science fiction-y to say that, but it's amazing what you guys have done with Windows 7. I just, I have to say that. This is a great step, and you started this step in Vista. Yeah, and this is really awesome.
It's an ongoing mission. Our team does a wide range of things. We got to drill into one aspect. We do remote assistance and ETW, but all of these tie into moving the mission in the direction that you just touched upon.
Excellent. Well, hey, thank you for your time. I know you're busy.
Thank you.
And congratulations on an excellent iteration of Windows.
Thank you.
Cheers.